So tonight I want to talk about how I've been enriching community science data using Survey123 and the ArcGIS API for Python to support the Jane Goodall Institute. So the project we've been working on with Jane Goodall is the Western Tanzania Decision Support and Alert System. One of the goals of this project is to engage community members in Western Tanzania to collect data on the status of chimpanzees and their habitats. The audience of this tool is first and foremost community members, but we're also looking to decision makers within USAID, Tanzania National Parks, and Tanzania Wildlife Research Institute. Tonight, we're going to be focusing on the threats observation. So it's a point data collected through Survey123. And you can see here, there are pictures collected from the village forest monitors of logging, poaching, and other farm animals and other threats. So when collecting and processing this data, we came across a problem of we have 15 different types of administrative polygons that we are trying to analyze this data against. And we want to be able to answer the questions such as how many threats are found in X chimpanzee corridor section that crosses through this village. Now, out of the box, ArcGIS dashboard capabilities allow for an or spatial intersect of these polygons, when in reality, we need an and spatial intersect of these polygons. So I'm going to go ahead and show you what that out-of-the-box tool allows for. So this is a map of the threats points, and you can see the chimpanzee corridors are in blue and the villages are in white. And as I said, there are 15 administrative polygons, but for tonight, and to make it a little simpler, I narrowed it down to 4 to look at. So if I want to look at the chimpanzee corridor of Gombe Ilagala. And I also want to see what's going on within the village Bubongo. You can see that it tells me the total threat number of almost 2,500 points, but it didn't really answer my question. It gave me the total number of both of those polygons, when what I was looking for was the intersect here. So to solve this problem, we decided to hook up Survey123 to a hosted Jupyter Notebook within the ArcGIS Online environment, and we run it daily using a spatial intersect. So I'm going to go ahead and hop over to the notebook. And the first thing we're going to do is connect to the GIS and import the mini modules that we need. Then we're going to call our layers. So we're going to call our polygon layer, and we're going to call our points that are coming in live from the Survey123. Then we're going to convert them to a spatial data frame. But first, I want to take a look at this polygon layer. In order to not iterate 15 times through a spatial intersect, I decided to union all of these administrative polygons together so that we can run through the spatial intersect once and get the same value. Make it a little bit more efficient. I'm going to convert that polygon to a spatial data frame, and I'm checking the spatial reference just to make sure it's going to go through the spatial intersect. Then I'm going to query the points layer for any point that has not already been joined. So any value or any point that doesn't have a spatial join value. Turn that into a spatial data frame, ask how many points are actually being updated today, and check the spatial reference. All right, so now I'm ready to spatially join. I join the spatial data frames together using an intersect here. And I calculate the join fields. So based on the polygon fields, I calculate the point values. Clean up that join a little bit, make it a little less messy. And you can see that we have now populated this table with district join and refugee join for these points. Village join and corridor join were not calculated because those points did not lie within either of those boundaries. One last cleanup step is to query for any point, is to remove any points that didn't have any join, meaning they fell outside of any administrative polygon and don't need to be updated. All right, now we are ready to actually update our feature service. So step 1 is to create an empty list here, where we're going to append our newly created and newly updated feature points. Then we query for all of our points, and you can see that takes the longest time, coming in at about 1 minute and 23 seconds for 30,000 points. This chunk right here is really the meat and potatoes of this workflow. This is where you take your pandas data frame and you update your feature service with its values. And so I query base on the global ID and deep copy into it and calculate the values again. Once the feature has been updated, it gets appended to that empty list we created in the first part. This prints out as each one populates and lets me know that 15 features were updated. Now I'm ready to actually apply the update function within the ArcGIS API. One small quirk of the API is that it does tend to time out about 250 records to update, so we have it chunked so that it will keep looping. All right, now we're ready to hop back to the story map and see what the heck that just did. So this dashboard shows you what that spatial intersect allows us to do. Same dashboard with that capability. So chimpanzee corridor Gombe-Ogala, village Bubango. And you can see that instead of 2,500 total threat observations, we get 18. So a very different answer to the same question. Now there are way more possibilities for this kind of Survey 123 to Jupyter Notebook hookup. You could identify features with attachments for QA, QC workflows. You could break down timestamps into other larger breaks. You could aggregate or summarize point trends at larger polygon scales, or you could enrich points by joining to other data sets. Anything that tells a better story of your data without putting a heavier burden on your actual surveyors. Thank you.